The Atomic Energy Lab, produced by the A.C. Gilbert Toy Company, was produced in the early 1950s and remains one of the most intriguing and controversial toys ever marketed. Designed as an educational product to inspire young minds in the realms of physics and chemistry, the lab was a testament to the post-war fascination with nuclear science. However, it also raised significant safety concerns, particularly by modern standards, that have led to its legacy as an infamous example of hazardous toys. Key safety concerns. Radioactive materials. The most glaring safety issue with the Atomic Energy Lab was its inclusion of actual radioactive samples. The kit contained 4 uranium cores that emitted alpha, beta, and gamma radiation. While the radiation levels were relatively low, the cumulative exposure over time posed risks, particularly in unsupervised settings where children could mishandle the samples. Long-term exposure to radioactive materials, even at low levels, is now known to increase the risk of cancer and other health issues. At the time of the lab's release, public understanding of radiation dangers was limited. The Atomic Energy Commission had not yet established strict regulations for the handling of radioactive materials, and the risks were downplayed in marketing materials. Such oversight would be unthinkable today, given our current knowledge of radiation safety. Lack of protective measures. The kit did not provide adequate safety instructions or protective equipment. There were no gloves, lead shields, or proper warnings about the risks of direct contact with radioactive materials. Children were encouraged to experiment freely, and while the Geiger counter added an element of measurement and discovery, it did little to mitigate exposure risks. Accessibility of hazardous components. The lab's design made it easy for curious children to access radioactive materials without realizing the potential consequences. This lack of protective barriers or secure storage for such hazardous components amplified the risks, especially in homes with younger siblings or pets that might inadvertently come into contact with the materials. Potential for misuse. Although the kit was designed for educational purposes, it could easily be misused. Without strict supervision, children could tamper with the materials in ways that amplified exposure or created unsafe conditions. The absence of clear guidelines made it challenging for parents to ensure the experiments were conducted in a controlled and safe manner. Broader exposure risks. Another concern was the potential for radioactive contamination in the home environment. Dust from handling uranium or, for instance, could spread to surfaces or even become inhaled. This presented a risk not just to the child using the kit, but to the entire household. Conclusion. The Atomic Energy Lab was discontinued in 1951, less than 2 years after its launch. While it was a product of its time, a period characterized by unbridled enthusiasm for science, it serves as a sobering reminder of the need for common sense in product design. Let's analyze the example. Which supports and barriers were in play? What were the dynamics? Who, or what, won the tug-of-war? Discuss the outcome with your friends and family. Use Post 4 as a reference for the dynamics and relationships between supports and barriers. Thanks for watching.